logarithmic function. Logarithmic function, the derivative of log x base b is equal to 1 over x ln b, and the derivative of ln x, that's the logarithm of x, is equal to 1 over x. So let's have, for example, we have differentiate y is equal to ln s plus 1. So what you just said that let u equal to s squared plus 1. So if u is equal to s squared plus 1, let's find the u, the x is equal to 2x, and recall that y is now ln u, and dy du, which is u, as I said, is 1 over u. So to now find dy dx, we apply chain rule that says dy du times du dx, which is equal to 1 over u times 2x. So the final answer will be 2x over what is our u? S squared plus 1. So this is the value for the example. For this example 2, so you said let u is equal to sine x. So just write to y is equal to ln sine x, and you know that u is equal to sine x. Therefore the u dx is equal to cos x, and you know that by the time we write u, y is ln u, dy u to give you 1 over u. So meaning that the y dx will now be the y du times du dx, which is equal to the y du is 1 over u times cos x, which is cos x over sine x, which will give us cos x. So that is differentiation. So if f of x is square root of ln x, to find f of 1 prime, I've done this example earlier before in the one of the video that you are going to apply the chain rule twice, which will be, before you write it and see, you are going to now have ln x all raised to power 2. So meaning that the f of x will fall into 1 over 2 onto ln x. So minus 1 over 2 dot d ln x. So f of x prime will now be half onto ln x raised to power minus half dot 1 over x, that is derivative of mean x. So by the time we writing this one is half. Everything will be 1 over 2x. Going to the minus of half of this will be square root of the x. So this is just the answer. Example: differentiate f is equal to log 2 sin x is 10. You still remember this formula 1 that I wrote from the beginning of this lecture. Had something like this. So the f of x prime will just be. So our b is the base. So the lane of the base and the real value. So we now have 1 over 2 plus sine x. Now lane 10. But due to the fact that it's a function of a function, so we multiply the derivative of 2 plus sine x. So f of x prime will be the derivative of 2 plus sine x will give you cos x over 2 plus sine x lane 10. This is how we apply the formula to get the answer. Example 5. Find the derivative of limit x plus 1 all over x minus 2. So just apply the formula by applying the chain rule. It will give you. So the answer will be 1 over x plus 1 all over root x minus 2. Derivative of x plus 1 on square root of x minus 2. So recall that to apply the derivative for this, what you are going to do is you are going to apply the quotient rule, which will give you. So this will firstly reciprocate. You have x minus 2 over x plus 1 onto. So by applying the quotient rule, we have the so let's apply the v du the x minus. So this is u. So we have the square root of x. This one is the square root of x minus 2. So of x minus 2 dot derivative of this given one minus x plus 1 x plus 1 derivative of given 1 over 2 onto x minus 2 all to the power minus half dot 1 divide by the v square, that's root x minus 2 all square. So therefore it will be equal to root x minus 2 over x plus 1 bracket open. By the time you multiply this, we have the square root of x minus 2 minus x plus 1. So write the same thing onto x minus 2 all raised to power minus half over. So these two cancel this thing. So we have x minus 2. Now let me multiply By the time we multiply this, the root x minus 2 to multiply the root x minus 2, it will give you ordinary x minus 2. This one is raised to power half and plus half. Recall, what do you believe will happen? You see in the next page. For better explanation, we have x. So the expansions of this is that the x minus 2 multiply x minus, you have the square root. So what will give us is this root and this root, it is half. So half plus half will give us 1. So it will be equal to x minus 2. Now this one is raised to power half. It will be a raised to power half times a raised to power minus half. To give us a to power minus half plus half. So it will be a raised to power. So it will be a raised to power 0. A raised to power which is 1. So meaning that multiply root x minus 2 and this will give us 1. So therefore remain minus x plus 1 all into half over. So this is now x plus 1 bracket open bracket close bracket we have x minus 2. So find the xm from this area, from this angle we have x minus 2 minus x plus 1 all over 2 over 1 over 2 x plus 1 onto x minus 2. So from here we have 2x minus 4 minus x plus 1. So if you able to see that, we discover that from the angle this is x plus 1. The minus will multiply minus x and this. So this one will give you minus x minus 1. So the moment is minus x minus 1. So you will now add it together. So you now see that 2x minus x will give us x minus 5 over 2 times, because these two by the time I'm trying to find the xn still remain 1 over 2 here. So therefore we have 1 over x plus 1 onto x minus 2. So the final answer is x minus 5 over x plus 1 onto x minus 2. So these two will now be here. So this is the final answer. Here, example 6. Find derivative of f of x. So if f of x is ln x, so what exactly to do is that the f of x will be, because it's a modulus of x, will give us ln x ln, because these are the range of if it will be ln x if x greater than 0, and also it will be ln minus x if x less than 0. So you just have to understand this first. So it follows that, so the derivative of f of x will now be the to be in two functions. So when you differentiate this, to give you 1 over x. If x greater than 0, this one will give you, because of the inner functions of a function, to give you 1 over minus x times minus 1. By the time you use share rule, so you now have 1 over x. Now find if x less than 0. So just have, so thus f of x prime is equal to 1 over x for all x is not equal to 0. So that just meaning that for all x is not equal to 0. So example 7. So this is logarithmic differentiation. So for solving this, what you do is you find the logarithm of the both sides, which is ln y is equal to ln x 3 over 4 root s squared plus 1 onto ln 3x plus 2 5. I want you to remember the law of logarithm that says that q, let's just say that we have pq divided by k, let's say base a, can be written as log p plus log q minus log k. This is the analogy. This is the law for a logarithm. So for having a question like this, what we now have is ln y is equal to ln 3x raised to the power 4 ln x raised to the power 3 over 4 plus ln square root of s squared plus 1. Now, so this is division, minus ln 3x plus 2 minus ln 3x plus 2 all raised to the power 5. So this is how the logarithm will make it too simple to solve. You just apply the logarithm to, so but you still remember some laws of logarithm says that if you have a log x plus 2, let's say log p raised to the power n base a, can be written as log p a. So in view of this, you can write all this to have 3 over 4 ln x plus this one raised to the power half already, 1 over 2 ln x squared plus 1 minus 5 ln 3x plus 2. So solving any equation with logarithms make it easy. So let's differentiate. Remember that this is an implicit it falls to implicit. If you have to differentiate ln y to give you 1 over y, the y the x, which is 3 over 4 dot 1 over x plus 1 over 2 onto the length of this. By the time you apply the quotient rule, so this will be 1 over this dot derivative of 2x. So it will be, when you differentiate this, will give you 2x in multiplying of x squared plus 1. That is the analogy. Now minus 5 dot, the same thing applicable to when you differentiate this to give you, it's 1 over x, it will be 3 on 2, 3x plus 2. So now in having this, let's try to expand this 1 over y, the y, the x will give you, this will be 3 over 4x plus this will cancel this, we have our x onto x squared plus 1 minus 15 over 3x plus 2. So this is how it is. So the final answer, you just multiply y with this to have the y, the x is equal to, so by the time you multiply y, it will be y onto bracket open 3 over 4x, 3 over 4x plus x over x, x all over x squared plus 1 plus minus 15 minus, this is 15 over 3x plus 2, 15 over 3x plus 2. So this is the final answer for the question. So that's all. So you apply the same thing. So let's apply to have a ln y is equal to ln x root x. So from the law of logarithms, this can be rewrite. So therefore, but this can also be rewritten as root x ln x, as I've said earlier that the powers of logarithms are written like this: log p raised to the power n base a can be n log p base a. So therefore, in differentiating this, remember it's an implicit differentiation. So we are differentiating these two lines now. So we have the differentiating ln y will give you 1 over y, so it will be y 1 dot 1 over y, which is equal to you apply the product rule to this, so we have uv, so which is ln. So in doing that, we leave root x, you differentiate ln x plus leaving ln x in differentiation. Differentiating this will be dot is raised to power half already, so you just say that the half you multiply, remember it will be 1 over 2 x onto minus 1 over 2, so that's what it will give you. So in better solution, so we have root x over x plus ln x over, this one will be, it will be 2 root x. So what you will do is that we find the xan before we multiply the value of y to it. If you're able to see, let's find the xan here. We have 2 root x. So therefore, this cannot cancel this due to the fact that, so since it cannot cancel, so if you are to now find the xn, it will give you a little bit a difficult way. But what you are going to do is, let's try to simplify this. So if we're able to simplify that, you get what I'm trying to say. So let's rewrite this. Recall that x raised to the power half over x can be x to the power half times s to the power divide by s to the power 1 to be s to the power half minus 1, which is s to the power minus half. So this entirely we change to 1 over, it will now be 1 over s to the power half, which will be 1 over root x. So therefore, let's change this. Let's change it to 1 over root x. So it will be easy for you now to simplify. So root x will cancel root x to give you 2 plus, so ln x. So and you know that y1 will now be the y will now multiply 2 plus ln x over 2 root x will now be the final answer.